Which of the following inputs will make the output of the function non-real? The function is the square root of the quantity x plus 2, and here are the inputs that we're going to check. We'll start with -6. F of -6 is the square root of -6 plus 2, or the square root of -4. When I have a negative underneath an even root, it creates an imaginary number, which is non-real. So the input of -6 did make the output non-real. Now we check what happens when I substitute in -4. F of -4 is the square root of -4 plus 2, or the square root of -2. Once I recognize that the part underneath the radical is negative, I know that my output is non-real. Let's check f of -2. The square root of -2 plus 2 is the square root of 0. The square root of 0 is 0. That is a real number. So the only issue is when the input creates a negative underneath an even root. But 0 is fine. Let's check what happens when I plug in 0. F of 0, the square root of 0 plus 2. Radical 2 is a real number. If I plug in 1/2, the square root of 1/2 plus 2. Now we don't have to actually add this together, but we just have to recognize this would be positive. So we just want to make sure we're not creating a negative underneath the radical. So 1/2 would create a positive underneath the radical, so it will not make the output non-real. And same thing with pi, the square root of pi plus 2. Pi is a positive number, 3.14-ish, plus 2, that's positive. So none of the remaining values will make the output non-real, just -6 and -4. Again, which of the following inputs will make the output of the function non-real? This time, the function h of x is the cube root of 6 minus x. Well, here, we're actually not going to have a problem with any input. So because this is a odd root function, I can substitute in any value because it's okay to have a positive or a negative underneath an odd root. We can check these values to confirm that. So here, h of -2, the cube root of 6 minus -2, that's the cube root of 8. The cube root of 8 is just 2. If I substitute in 0, I get the cube root of 6 minus 0, which is the cube root of 6. That's some number. Don't know what it is approximately without a calculator, but it is a real number. And now h of 7, the cube root of 6 minus 7, well, that's the cube root of -1. I have a negative underneath an odd root here. But there is a number that I would multiply to itself 3 times to get out -1. That is -1. We can have negatives underneath an odd root because when you multiply an odd number of negatives together, we get out a negative value. So to reiterate here, the answer is none. There are no inputs that will make the output non-real. In our last example, g of x is an even root function, the fourth root of the quantity 3x minus 4. So we do have to check these numbers. G of 1 is the fourth root of 3 times 1 minus 4. That's the fourth root of -1. I got a negative underneath an even root, so 1 is an input that makes the output non-real. If I check 4/3, the fourth root of 3 times 4/3 minus 4, the 3's cancel. I'm looking at the fourth root of 4 minus 4, or the fourth root of 0. Well, that's 0. No issues there. And finally, if I substitute in 2, the fourth root of 3 times 2 minus 4 is the fourth root of 6 minus 4, or the fourth root of 2. We did not create a negative under the radical.